For Unit 3, we're going to be jumping around and heading into Chapter 6, but before we do that, we're going to just touch on a few more things in Chapter 4. So we're going back to Chapter 4.4 and studying a few more things about right triangle trigonometry. So our objectives from this video, when you walk away, you want to be able to evaluate any angle formed on the coordinate grid. Before, when we were evaluating trig functions, we were limited to just the unit circle. So really, we never made it any further than a distance of 1 from our center or from our origin. So now what we're going to be doing is looking at any point on the coordinate grid and asking what are the trig functions of those triangles that are created, not just the ones on our unit circle. The other objectives are to be able to model right triangle situations given a trig function and then determine unknown sides and angles of a triangle. So this is one thing that I want to add, just so that you remember this, is that if you know two pieces of a triangle, of a right triangle, you know it all. Okay, so the idea is if I give you two pieces of a triangle and it's a right triangle, you can figure out every single other piece, the other sides, the other angles. Don't write this down, but what we had before is when we were evaluating angles on the unit circle, we would have these steps. So just keep those in mind. I mean, we used very special reference angles and very special triangles to be on the unit circle. So now we're going to not let any longer our terminal side length be 1. We're not on the unit circle anymore. Like we said, we can be anywhere we want. So with that modification, what we have are these steps. Okay, so we crossed out that step number 1. Now we're still going to use reference angles from the x-axis. We're still going to set up a right triangle with horizontal and vertical length to get to the end of a terminal side. We're going to use the Pythagorean theorem to find any unknown sides of a right triangle, and just as a review, that's a squared plus b squared equals c squared. So in other words, a leg squared plus a leg squared equals the hypotenuse squared. We're going to evaluate the six trig functions from the observed angle, and this is usually at the origin, and then we're going to watch out for negatives, set radicals, get radicals off the bottom, and simplify. So just as a quick review, don't forget our 6 trig functions are you input an angle, you get a side-to-side ratio. So these are all those side-to-side ratios if you need to refresh your memory, but so ka toa is what we are using. Alright, so here are the steps that are kind of outlined now in this section 4.4 as we look at any point on the coordinate grid. And number 15, this is going to reach our objective. One of our objectives is to be able to set up a triangle based off of any trig function given. So keep in mind they didn't give us an angle, but they did give us the side-to-side ratio of opposite over the hypotenuse. So what we have been used to in the past is something like sine of theta is equal to 1/2, and we have known that to be over 1. So what we would do is we would just look at, alright, where is there going to be a sine of 1/2? We would find that triangle and evaluate. Well, now we're going to have something other than those hot spots or those hot numbers for our sine, cosine, and tangent. So we're going to have to set up a triangle. This is the part that we know, okay? And they did have to give us a constraint, and I'll kind of talk about that in a second. So if we did set this up, we know that sine, the hypotenuse is always positive, so this has to be positive. The sine are the opposite length. When you are standing at the origin, what this is saying is the opposite side has to be the distance of 3, or a length of 3. The hypotenuse would be 5. And hopefully you're thinking, wait a minute now, there's another option. We could have drawn it over here where we have the length of 3 as the opposite side. And again, I'm standing at the origin, so there's my opposite over the hypotenuse, and that would be 5. So the constraint, though, is that our angle, so here's our theta, this is our reference angle, and we're saying our constraint is that this theta lies in quadrant 2. So this, I'm going to cross this side out, this is the triangle that we want. Alright, so be aware that whatever we find for this length, it's going to have to be negative. So when we evaluate all of those, we have to really watch out for those negative signs. So given two pieces, now I can find out every single other angle and side about this. We're going to first use the Pythagorean theorem So we formed that. We're using the angle from the x-axis, and we're going to now use the Pythagorean theorem. So a leg is what we don't know. A squared plus 3 squared equals 5 squared. And then we're going to then have a squared plus 9 equals 25. When we subtract off the 9, we're going to get a squared equals 16, and we're going to square root it, and it's positive or negative 4, but we're going to go with the negative one because we needed to go back. So now that we have all three sides, what we can do is evaluate this. So here is our reference angle. Cosine of our angle is then going to be negative 4, because there's my adjacent, over 5. Tangent is going to be opposite over adjacent. It's TOA. So we have 3 over negative 4 for an overall negative side-to-side ratio. Cosecant, easy enough, we're just going to flip these. So 5 over 3, 5 over negative 4, or negative 5 over 4, it doesn't really matter. And then cotangent is going to be negative 4/3. Alright, so our last thing is determine the angle in degrees. So now what I want to find is what is that angle. So since we're not on the unit circle, this is where we are going to have to use our calculators. So we have sine of theta is equal to 3/5. Well, hey, remember, I want to get this theta by itself. I want to know what it is, so how do I get rid of sine? Well, let's inverse it. Sine inverse of sine, they cancel each other out, just as multiplication and division do. So sine inverse of 3/5, when we do that on our calculators, what we are going to get is approximately 36.89 degrees. Okay, and you could have done that with any of these, so do keep that in mind. And technically, what our calculator got us is this angle over here, but note that they would be the same angle, but technically your calculator was thinking, you know what, we're in the quadrant 1 because the inverse sign would have been limited to those places. So let's do another one. Find the values of the 6 trig functions of this angle. So then what we are given this time is a tangent. So I'm going to go right ahead and say we need the 6 trig functions. So I am going to fill in this one because that one's already gotten for us. And honestly, I can just go ahead and fill in this. So hey, we're 1/3 of the way done. But now we're going to have to construct a triangle to do the rest. So here, don't forget, tangent is TOA. So what I got was an opposite over an adjacent. So opposite over adjacent, that's going to be that vertical motion over that horizontal motion. And now you might be asking, which one is it? Should I put the negative with the 15 or the negative with the 8? Well, I'm going to draw them both, and then we'll visit our constraint. And that's why we have it, is to answer that question, which one is it? So opposite, we do know would have to be, I'm going to say the positive 15, and then the adjacent, negative 8. So I'm going to go back 8 and positive 15. Okay, so there's this triangle. There's my reference angle. It's that acute angle formed with the x-axis and that terminal side. So here we have 15 and negative 8. Okay, so notice that I couldn't do it over here. You could try to sketch it, but then you would realize, hey, that's going to be opposite over adjacent, and that's both positive, so we wouldn't achieve the negative. The only other one that we could do here would be forward 8 and then down that 15. Okay, so here we have 8 and negative 15. So here's that reference angle. That's acute angle formed with that terminal side. Alright, so sine has to be less than 0. So in other words, let's kind of interpret what this means. If it's going to be sine is less than 0, then this means that the sine of the angle, whatever it has to be, is going to be negative, right? If it's less than 0, it's negative. So which one do we want? Well, we're going to cross out this one this time, because if we did do sine of this angle up here, it's going to be 15 over, we're not really sure what, but it's going to be 15 over something, and when we do that, it's going to get us a positive because our hypotenuse is always positive. So this is the one we want. So now, we could go ahead and try to start doing this thinking we've got it, but we need to get that third side. So here we go. We're going to have to do our Pythagorean theorem. This time we have 2 legs, and we're going to have to get our hypotenuse. When we do solve for this, we're going to get c equals plus negative 17, but we want the positive version, so I'm just going to fill that in. Alright, so sine is going to be negative 15 over 17. Cosine is going to be 8 over 17. And then now it's a matter of just flipping. Alright, so let's go ahead and take this. Let's determine the angle in degrees. So again, we could just use sine if we wanted to. Sine is evaluated on this side. So what we have is sine of an angle is equal to negative 15 over 17. And so the idea is, once again, we want to inverse this. So when we inverse this, what we're going to be getting is that theta is approximately negative 61.93 degrees. And do keep in mind, you could have used the tangent as well. We could have done tangent inverse and then tangent inverse, and we would have gotten the same exact answer, which is theta, crossing this out, theta is equal to, well, tangent inverse of negative 15 over 8 is going to be approximately negative 61.93 degrees. Here are your practice problems. I will say number 25 is a bit of a challenge, but try getting yourself a picture and you'll be set.